Geometry PSC 2, Lesson 3, Part 1. This is proportions with area and volume. Here are your objectives for the day. Let's go ahead and get started. Okay, so as I look at the ratio of the side lengths, smaller to larger for these two rectangles, what you'll notice is that the ratio from small to large is 1 to 2. The ratio of the areas smaller to larger is 15 to 60. Now, if I reduce that, that reduces to 1 over 4. And there's a very, very special relationship between these two items. One thing I'd like to bring to your attention is that this would be, let's say, centimeters. That'd be the measurement there. This would be centimeters squared, right, because it's area. And what you'll notice is that 1 squared is 1 and 2 squared is 4. Okay, so let's look at how that applies to another situation. The ratio of the radii is 1 to 3. Okay, we can see 1 to 3. If you would, you could pause the video right now and take a guess at what the ratio of the areas would be. Okay, so the ratio of the radii was 1 to 3. The ratio of the areas would be 4 pi to 36 pi. And when I reduce that, I get 1/9. So notice that 1/3 squared is 1/9. So as we look at this conjecture, if corresponding sides or lengths of two similar polygons or the radii of two circles compare in the ratio m to n, and the areas in the ratio, then their areas compare in the ratio m squared over n squared. Or another way to write that would be m over n squared. All right, let's do a couple examples. Okay, I like to make this table. It's this is your one-dimensional value, like your side length, right? This is your surface area or area, which is your two-dimensional, which is your area. And then we'll talk about volume in part 2 of this lesson, which is tomorrow. But I like to make this table. What you'll notice is that if I have a ratio of a over b, then my ratio for the areas would be a squared over b squared. And you might anticipate for tomorrow be a cubed over b cubed. So let's move on to a couple of examples using these tables. All right, so are these right circular cones similar? And the answer to that would be yes, right? I have congruent angles and I have proportional sides. So 14 over 21 is equivalent to 8 over 12. So by side angle side similarity, I know that these two right circular cones are similar. What is the ratio of their radii or heights? It doesn't matter which one I use here. What I'm going to do is I'm going to use radii 8/12, which I'm going to reduce to 2/3. Okay, that's the ratio of their radii. Let's call that for a second a over b. All right, what would the ratio of the areas of the bases be? Well, the ratio of the area of the bases would be a squared over b squared, which in this case would be 4 over 9. What is the ratio of their surface areas? Well, conveniently, you guys, their surface areas would take on the same ratio as the area of their bases. Okay, so surface area and area will take on that same ratio. Okay, let's keep moving, try another example. Okay, here we go, the triangular pyramid. These two triangular pyramids are similar. I'm told that the height of the smaller pyramid compared to the height of the larger pyramid is a ratio of 3 to 5. Okay, now that does not mean that this equals 3 and this equals 5. It just means their ratio is 3 to 5. So don't look into that as the actual height. Okay, so our one-dimensional ratio is 3/5. What would our two-dimensional ratio be? Well, it'd be 3 squared over 5 squared, which is 9/25. Okay, now I know that the surface area of the smaller pyramid is 13.5. Now, what I'm going to do is I'm going to take the ratio of the areas, which I said was 9/25. And if I know the surface area of the smaller pyramid, I'm going to look here at the smaller portion of this ratio, and I'm going to put that area right here. Okay, that means I'm going to find the surface area of the larger pyramid right here. I'm going to call that x. Let's call that x. Okay, so this is going to be equal to x. Okay, so we do a little cross multiplication. Let's go ahead and do that. So I get 9x is equal to 337.5, and then I divide by 9, and it looks like x equals 37.5 centimeters squared. Now, recall, this is the surface area of the larger of the two pyramids. This is the surface area of the smaller of the two pyramids, and they take on this ratio of 9/25. Okay, let's do another example. Okay, the right cylinders are similar. We need to be told that right away. We know the ratio of the surface areas is 4/9. What would the ratio of the radii be? Someone will do this, no doubt about it. They will say 16/81, and that is incorrect because we're going from two-dimensional to one-dimensional. If you go from 2 dimensions down to 1 dimension, that means you take the square root. Right? So I'm going to take the square root of each of those, and it looks like I get a ratio of 2/3. Therefore, let's fill in this table real quick. This would be 4/9. That was given. This is going to be 2/3. It says if the radius of the large cylinder is 21, what is the radius of the small cylinder? Okay, when it asks you for radius, you want to think one-dimensional. So 2/3 is the ratio of small to large. I know the large is 21. I don't know the small. I'm going to figure it out. So 2 times 21 is 42. 3 times x is 3x. Looks like if I divide, I get 14. Okay, you can just go back and confirm, right? So the radius of the small cylinder is 14. Is that smaller than the radius of the large? Yes, it is. At a ratio of 2/3? Yes, it is. You could even confirm that. Is 2/3 equal to 14/21? You could confirm that by cross-multiplying. That's 42, and that's 42, so it checks off. Okay, let's see what we got. Okay, you can go ahead and get started on lesson 3, part 1. You can ask any questions that you've got during work time or before or after school help. Like, subscribe, comment below.